So now here's some examples using the half-life formula. Let's say, for example, you have 100 grams of a radioactive isotope with a half-life of 10 years. So you have your initial value, A, is 100 grams. And the half-life, 10 years. That means every 10 years you lose half of it. They said, how much will you have left after 10 years? Well, if you have 100 grams, this question is pretty straightforward. After 10 years, you're only going to have half of that. So you're going to have 50 grams. How much will you have after 20 years? Well, after 20 years, if you started with 100 grams, after 10 years, you only have 50. After another 10 years, you're going to only have 25. But let's go ahead and plug it into our formula. So we have y is equal to 100, and then half, because it's half-life. And then we started after 10 years, but it's 10 for the half-life. 10 over 10 is 1. So y is equal to 100 times half raised to the power of 1. So that's why we're going to get 50 for after 10 years. And then if we did it for after 20 years, it's y is going to be 100. And then it's half raised to the power of 20 over 10, which is just going to be 100 raised to the power of 2. 1 half raised to the power of 2 is 1/4. 1/4 of 100 is 25. So that's how to think about it conceptually. How many half-lives will occur in 40 years? Well, in 40 years, you will have 4 half-lives occur because the half-life is every 10 years. Let's look at another one. So let's say, for example, they say the half-life of plutonium-236, so this is another place where you'll see half-life, is 24,300 years. So that's the half-life of plutonium. Half-life. So that means every 24,300 years, half of it is gone. If a nuclear bomb is released with 8 grams or 8 kilograms of this isotope, how many years will pass before the amount is reduced to 1 kg? So if 8 grams, so we started with 8 grams, so 8 grams. And then they said if 8 grams of the isotope, how many years will pass before the amount is reduced to 1 gram? We want to see when it will take for it to be 1, and it's always losing value, half of its value. It says 2, so we don't know the total time to get to 1, but we know that every 24,300 years, half of it is gone. So then we try to find out. We're saying, okay, at what point would it take it to get to 1? So 1/2 raised to the power of t over 24300. So 1/8 equals 1/2 raised to the power of t over 24300. So now we can either use our exponent rules or we can go ahead and use our calculator. So I'm going to go ahead and just use our rules. I know that 1/2 raised to the power of 3 is equal to 1/2 raised to the power of t over 24,300, because these two are the same. So 3 is equal to t raised to the power of 24,300 using some of our rules that we know. So I'm going to multiply. I'm going to do both sides by 24,300. So I know that 3 times 24,300. So that means in 72,900 years. In 72,900 years, then this plutonium will reach 1 gram. The 8 grams of plutonium on the nuclear bomb will reach 1 gram left in 72,900 years. So this is how you do half-life problems.